Okay, so we're going to go over the assignment. And again, for those of you watching at home, if you need if you need extra practice, please come into school before school on Monday or Tuesday. Remember, the test will be on the Monday if you're odd class, Tuesday if you're even. Okay, all right. The first one should have been 4Al plus 3O2 yields 2Al2O3, and that is a synthesis. All right, everybody good? Awesome. All right, for number 2, it would just be CH4 plus 2O2 yields CO2 plus 2H2O, and that is a combustion. All right, number 3 is the only thing you have to do is put a 2 in front of the KCl, and that's a double replacement. Okay. 4, this one is actually balanced. It is a decomposition. Like I said the other day, this is what's going on when you open a soda. Carbonic acid is not stable. All right. So it splits up into water and carbon dioxide bubbles. You see the bubbles come out. That's why flat soda tastes watered down, because it literally chemically waters itself down. Isn't that crazy? All right. Number 5 should be V2O5 plus 5Ca gives you 5CaO plus 2V, and that is a single replacement cationic. Cationic. Why is it cat? Because the positive thing changes, right? Positive thing gets kicked to the curb. Dun, dun, dun. Okay. Now, again, if I have one like this on the test, I got to double check. If I give you an organic compound, I will give you the formula. All right. So it should be C5H12 plus 8O2 yields 5CO2 plus 6H2O, and that is a combustion reaction. Number 7. All right. Sodium is just Na. Zinc iodide is ZnI2 because zinc is 2 and iodine is -1. Gives you sodium iodide, NaI, and zinc. And then to balance it, you need a 2 in front of both NAs. All right? And that is another single replacement cationic. Somebody mentioned that there was more cationic than anionic. And that makes sense, because are there more positive or negative ions? Positive are all our metals, negatives are our nonmetals, right? So it makes sense that there would be more cationic than anionic, because there's more opportunities for positive things to switch places. All right. Let's see. Calcium plus nitrogen is Ca. Remember, nitrogen is one of our H bond cliffs, so it should be N2. All right. And then to balance the charges, it'd be Ca3N2. So the only thing you have to do is add a 3 in front of the Ca, and that is a synthesis. All right. Iron 3 oxide is going to be Fe2O3. Remember, the Roman numerals is charge, not how many. So Fe2O3. Hydrogen gas is H2, and then Fe plus 3H2O. And so you get, or excuse me, you would have to have a 3 in front of the H2, a 2 in front of the Fe, and a 3 in front of the H2O. Again, single replacement cationic. Boron nitride would be Bn. All right. Then fluorine gas is F2, gives you BF3 and N2, and so you'd have to have 2, 3, 2, 1, and this is a single replacement anionic, because the negative thing is what switches places. Are you with me? Okay, let's go over the backside. Oh, this is where we had to predict. Okay. So lead 2 nitrate would be PbNO32, sodium iodide, NaI. So, in this case, lead is going to end up with the iodine, sodium would end up with the nitrate, and again, the charges are going to stay the same, so PbI2, and then NaNO, so you'd have to have 2 in front of these. Now, please pay attention. If you wrote it the other way, and you had, and by the other way, I mean, you just flipped these two, so you had 2 NaNO3 plus PbI2, that is fine. As long as you have the right things with the right partners, it doesn't matter which one you write first on your product side, okay? all right? As long as the right things are combined together in the right way. And that is a double replacement reaction, all right? Okay, barium hydroxide plus hydrochloric acid, so BaOH2 plus HCl gives us barium chloride and water, okay? And you could have wrote it as H2O or HOH. Either way works, all right? And so to balance it, you need a 2 in front of the HCl and 2 in front of the HCO. And again, that's a double replacement. Everybody switch partners, all right? Silver plus sulfuric acid. You got Ag. Remember, all acids start with hydrogen. If it doesn't have hydro, it's going to be the polyatomic ion. So the it goes to the A. We find the sulfate, and it takes 2 to balance it. Gives us silver sulfate. So Ag2SO4 plus hydrogen gas would be kicked out. This would be a single replacement cationic because the positive thing's getting kicked out. Going onward, aluminum plus chlorine. So Al plus Cl2 gives me AlCl3, and you'd have 2 aluminums plus 3 chlorines, or Cl2s, gives me 2 AlCl3, and that is synthesis. And last but not least, heptane, C7H16 plus oxygen gives us CO2 and H2O, and that's combustion. And you'd have to have 11 oxygens, 7 carbon dioxides, and 8 H2Os. All right? Any questions that you want me to work one out all the way for you so I can show that before I stop recording? Do 15? Yeah, we can do 15. That'd be a good one to work out because it's one of the... So heptane, guys, please, let's stop the side conversation, even if you got them all right. Okay, so C7H16, right? Plus O2. All right? So we need to recognize anytime we have a hydrocarbon, and again, it's normally written with the carbon first, but we call it hydrocarbon. I don't know why. All right, plus oxygen, that's going to be for what we are doing a combustion reaction. The product for complete combustion is always going to be CO2 and H2O. All right? When we do this, write your elements down below. Okay? Oops, that's it. All right. I had some people see CO2 and they're like, can I keep CO2 together? CO2 is not a polyatomic ion. And even if it was, in order to keep it together, it's got to be on both sides the same. All right, so you can't. So over here we have 7, 16, and 2. And over here we have 1, 2, and 3. Okay? All right. When you're doing these, do not forget your oxygen's in 2 places. So as I change numbers, I have to re-add. Don't just try and add to the bottom. That's where people make mistakes. So I can start with my carbon. If I put a 7 here, that's going to change my carbon to 7. That makes these oxygens 14. If I just add 14 to 3, I'd have 17, which would not be correct. I have to add the 14 plus the 1, and I'd be at 15 right now. And then I've got 16 and 2, so I'd put it 8 in front of my water, making it 16. 8 times 1 is 8. What's 14 plus 8? 22. I don't know about you, but the answer is 22. All right. So to make this 22, I'd have to put an 11 here and make it 22. All right. Does that help? The big thing, guys, on these ones is the oxygen. Make sure you re-add it each time you change a number. All right? Okay. Any other questions? All right. By a show of hands, how many think the hardest part is balancing? Just doing the balancing. Okay, a few. I'll get you some practice with that. How many think yes. Oh, you're balancing is the hardest part? Okay. How many think the hardest part is writing the formulas? Okay. How many think the hardest part is predicting the product? Okay, I've got extra practice for each of those. So I will get those out to you. And remember, we got quiz on Monday. Let me stop by recording.